Hi guys, today we're going to take a look at the if-then statement in mathematics, and it is really important in mathematics, and which we'll see why later on as we progress in calculus. So what's the if-then statement? Let's for example, maybe if x is a dog, I like dog, then x is an animal. We call this a if statement for obvious reason, right? It starts with the if, then. So mathematicians are lazy. They like to write it as if px then qx, where it's simple as the px basically means the statement x is a dog, and qx basically means the statement as x is an animal. So they just simplified it as if px then qx. Then in what mathematicians do in the interest of removing words is that they simplify it further because they don't want any like English words in their mathematical statement. So you can actually further simplify it even more to px implies qx. So what this implies mean is that if px is true, let's actually write that down, because these are the two properties of a if-then statement that I'm going to talk about right now. So the first property of a if-then statement is that if px is true, then qx must also be true. So if px is true, then qx must also be true, which is gonna work in this example here. If x is a dog, then x must be an animal. There's no single breed of dog that is not an animal. If it's a dog, then it is an animal. So if px, which is the first statement, x is a dog, is true, then the second statement, which is x is an animal, must also be true. So that's the first property of the if-then statement. The second property was that if px is false, which is if x is not a dog, then qx doesn't mean anything. This is actually pretty obvious as well, because the whole point of the second statement, x is an animal, is all established on the fact that x is a dog. So if x is not a dog, then the second statement doesn't mean anything, because the whole point of the second statement is that qx is basically based on px. So if px is not true in the first place, then qx should not serve any purpose. And this is the one way of writing it. Let's actually rewrite that. Px implies qx. In this case, px implies qx means that if x is a dog, then it implies that x must also be an animal. So there's this is one sign. There's also the opposite sign. If we write it as px, the opposite arrow of qx, what it means is that qx implies px must be true. But in this case, it's not going to work, because if our px statement is if x is a dog, and our qx statement is x is an animal, but if we write it in the opposite arrow way, what this is saying that they switches the order. If x is an animal, then x is a dog, which is untrue, because there's cat, there's mice, there's whatever else animals, there's lions, there's tiger. So if x is an animal, it might not be dog. So in this case, if we write the opposite arrow, this statement would be false. And there's also the third one, which is this arrow right here, which is like the two side arrows that points to each other, which means that if you switch order, so whether or not you start with if px then qx, or if qx then px, they're all true. So in this case, you'll use this arrow as they implies each other. They both stand true no matter you switches the order. So we just got introduced to this sign, the opposite arrow, and the arrow that points to each other. So this implies the first statement implies second statement is true. This is second statement implies first statement is true. This is, no matter how you switch the order, they're both true. So you just learn these signs, and they will come pretty important later. because you will see a lot of quantifiers and step builder notation with these if then statement, which will be important in our proof. And thank you.